In this video, we're going to talk about adding and subtracting rational expressions that have like denominators. That means they have denominators that are the same as each other. So if we have P over R plus Q over R, those have the same denominator. In this case, that's R. So we are able to simply add the numerators, P and Q. Similarly, if we want to subtract, if they have the same denominator, we're going to be able to subtract their numerator. So P over R minus Q over R is P minus Q over R. Okay? Please note that you are not adding or subtracting the denominators themselves. All right? The denominator will stay the same at the end of addition and subtraction. So let's take a look at an example. Let's say we have 11x plus 28 over x plus 4 plus x squared over x plus 4. Notice that x plus 4 is the same for both of our fractions. That means when we're adding the two fractions, we're really just adding the numerators and keeping x plus 4 as the denominator. So we're going to add our numerators, and we look at it and we say, okay, is there anything we can combine? Are there any like terms in the numerator? Well, no, there aren't. However, we can rewrite it in descending order. So that means x squared plus 11x plus 28 would be the proper order for the numerator. Now when we look at that, we can ask ourselves, is that factorable? Because we can simplify. So keep in mind here that when we're doing these addition and subtraction problems, we're not actually just adding or just subtracting. We are then looking at what the result is and seeing, can it be simplified? So in this case, it can be, because x squared plus 11x plus 28 can be factored to become x plus 4 times x plus 7. And remember, that's because 4 times 7 is 28, and 4 plus 7 is 11. So those are the numbers that work out. Now, as you probably have noticed, x plus 4 is going to cancel, and we're left with just x plus 7. Pretty nice, huh? Now, one thing we do want to go ahead and mention here is it is x plus 7 for every value except x equals negative 4. So let's talk about why x equals negative 4 is not allowed. Well, when we look at our original expression here, okay, notice that the denominator is x plus 4. We cannot divide by 0. So because we can't divide by 0, x plus 4 is not allowed to equal 0. So subtract 4 on both sides, we see x cannot equal negative 4. So even though we were able to simplify the expression, the original constraint that x couldn't be negative 4 still applies to our answer. So that's why we would say x plus 7 when x does not equal negative 4. All right, so basically there's a hole in our line at negative 4. All right, let's try another one. This one's going to be subtraction. Notice here that the denominators are the same, so we are going to be able to subtract their numerators. One thing I like to do is put parentheses around each numerator, because keep in mind that when you're subtracting a fraction, you're subtracting the whole numerator. That means the negative applies to everything in the numerator. So we're going to break it up like this, and you don't have to put parentheses around the first grouping. You'll notice they didn't do that here, and that's okay. Because the negative is the important part. You're going to distribute that negative, and that's going to become negative 4x squared minus x plus 9 in the numerator. Now you're going to be able to combine like terms. So 5x squared minus 4x squared is x squared, negative 7x minus x is negative 8x, and 3 plus 9 is 12. So now we have a polynomial on the top and a polynomial on the bottom. Guess what? We're going to factor. I know, you love that. So we're going to factor x squared minus 8x plus 12, and we're going to factor x squared minus 3x minus 18. When we do that, we get x minus 2 times x minus 6 over x plus 3 times x minus 6. And you'll notice those x minus 6's cancel. So voila, our simplified version is x minus 2 times x plus 3. Keep in mind, you should always double check what x values do and do not work. All right, let's do another one. In this one, you'll notice again, we're subtracting, but it doesn't look like our denominators match, and that's because they don't, but they're really close to matching. So when you look at m squared minus 1, it is almost exactly the same thing as 1 minus m squared, okay? But if I were to do negative times 1 minus m squared and distribute the negative, that would give me negative 1 plus m squared, which is the same thing as m squared minus 1. So if I were to multiply through by a negative to the denominator, it would make that denominator the same as the denominator of the first fraction. So what we're going to do is we're going to multiply that second fraction by negative 1 on the denominator, but what you do to the bottom, you have to do to the top. So we're really multiplying top and bottom by negative 1, okay? Now I distribute that negative 1 to the denominator and I rearrange it. I get that m squared minus 1, as we said above. I also want to distribute the negative 1 to the numerator. That's going to give me negative 3m minus 2. Now I'm going to subtract the numerators because my denominators are the same. Yay! And in this case, just notice that I now also need to distribute this negative in between. If you wanted to, instead of distributing this negative 1, go ahead and skip to this combination where it's minus the negative and that cancels, you are totally allowed to do that as well. So if that makes sense to you, great. If you have no idea what I said, just go with this method. It's fine. So anyway, when you distribute, we're now going to be able to combine the like terms, negative 6m and 3m. Those combine to give us negative 3m in the middle. I can now factor both the numerator and the denominator. The numerator becomes m minus 1 times m minus 2. The denominator becomes m minus 1 times m plus 1. And the m minus 1's cancel, leaving me with m minus 2 times m plus 1. All right? And that is simplifying after you've done adding and subtracting of rational expressions with like denominators.